So, a little bit of review. Yesterday, we learned reciprocal functions. So if I tell you the number 2, if I tell you the number 2, and I say, what's the reciprocal of 2? You would say, it's 1 over 2. So if I give you x, I say, what's the reciprocal of x? You're going to say, 1 over x. 1 over x. Pretty basic. Okay, so then we took reciprocals and we graphed them. Right? So that's what we're going to do today. But now our graphs are going to get a little more complex. The system that we follow, remember we had 3 steps. Still the same. So that's the nice part. Even when things get hard, they actually are the same. It's just more of the same. This question, which statement about this is false? The graph has a vertical asymptote. Vertical asymptotes are, if you have a graph, it's a point on the graph where you draw a line, a vertical line. It looks like that. And your graphs, they come up to these vertical lines, but they never touch the vertical line. And they just go off into infinity one way or another, but they never actually touch that asymptote. It's like my ability to do graph dot. So close. It'll never happen. Will never happen. I'll try forever. It's not going to get there.
I love that analogy.
That's an asymptote. Where do we get vertical asymptotes? They're your non-permissible values. Yeah. So if you look at our equation, is x equal negative 1/2 a non-permissible value? It is.
Yes.
So if you put in negative 1/2, you get 0 on the bottom. Can't divide by 0. That's how you get vertical asymptotes. So that's true. So it's not that. B. The x-axis is a horizontal asymptote. That's true because it's always true. So if you were here, we always have a horizontal asymptote on the x-axis in this class. Always. The Math 30-1s right now are suffering through the idea that it moves. Four souls. Part C, yeah, you do. The graph has an x-intercept at negative 1/2. Well, let's think for a minute. If I have an asymptote at x equals negative 1/2, can I have an intercept at negative 1/2? No, you can't. You can't have a value there. You're kind of right. So we're going to talk about that. But no, you can't. You can't have an intercept where you have an asymptote. So that's your false statement. It's not possible. Or you could look at the picture and just try it and be like, oh yeah, that doesn't work. D is obviously going to be true, but let's look at it anyway. The domain, so the possible values of x, is XER, where x cannot equal 1/2. That is true. So the only restriction on this graph is x cannot be negative 1/2. So that's true. Ibrahim.
For like the they'll probably have like the line of like the original equation after reciprocal. Right?
So we're good.
But
so the original, yeah, that's why he said, yeah, it does. It's kind of right because the original thing. So if it wasn't the reciprocal, it would happen. But it is a reciprocal, so it doesn't. That's what today's all based on. So there's a reason for our madness. Okay. The second part. The second question is something we learned. It's called an invariant point. An invariant point. This was the other key. So we had asymptotes and we had invariant points. And if you don't know what the word invariant means, you're not alone. But you do all know what the word vary means. So if something varies, it means it changes. So if it was invariant, it wouldn't change. So points that don't change. That's what invariant points are. So what that means is if you took a graph, like this one right here, this beautiful red line, and you took the reciprocal of that, there would be some points that are on both this graph and the reciprocal graph. Those points are called invariant points. Who remembers where they're always found? Yeah. They're always found at y equals -1 and y equals 1. So if we look at this original graph, y equals -1 here at A, and y equals +1 here at C. So those would be your two invariant points when you go to graph the reciprocals. So A would be our answer.
And are the points always on like the original line?
And it's always, yeah, they're always on the original line.
Is there always two?
Great question. Sometimes there's 0. So it all depends on what your graph is going to be. And that's what we're going to do today. Sometimes we're going to have 0 invariant points. Sometimes we're going to have 2. Sometimes we're going to have 1. All depends on the graph. Okay, today, what makes things harder is we're now going to start doing quadratics. So when you have a reciprocal of a quadratic, there's 3 types of graphs you're going to get. You're going to get this kind of graph, where there's no asymptotes. You're going to get that kind of graph, where there's one hidden asymptote right there. And you're going to get this graph, where there's 2 vertical asymptotes. One here, and here. Those are the only 3 types of graphs you're going to see. The other way you can see each of them is upside down. So you can see the one below is the same graph but flipped. So there's only 3 types. You might see it upside down. You might see it right side up. This first one, with no vertical asymptotes. Why do you think it has no vertical asymptotes? Ibra. So x can be anything. So there's no non-permissible values. So if there's no non-permissible values, what would the original graph look like? It would look like there's no x-intercepts. So how do we get a quadratic with no x-intercepts? Well, looks something like that. So if that was your original function, and you wanted to take the reciprocal, it turns into that. And alternatively, if it's upside down, that just means your graph was upside down. Asymptotes are created by x-intercepts on the original function. So if there's no vertical asymptotes, the original graph never crossed x. There's no non-permissible values. There's no point where it's equal to 0.
So if it touches the x-axis twice.
That's a great question. We're going to do one time first. So what do you think happens if you have one asymptote? It means it came down, touched it once, went back up. This is just the upside down version of that. So touch right here. So x-intercepts cause asymptotes on the original function, or on the reciprocal function. So this one, we've got 2. So what do you think this graph is going to look like? It's going to have 2 x-intercepts that cross exactly at the asymptotes. This one's going to be the same, just upside down. So the red would be the original. The black lines that were already drawn there would be your reciprocal graphs of the red graph. That's a little tricky, but that's what we're going to do today. We're going to work with these things, these ideas. You guys seem like you're kind of getting this, like, pretty good. Like, yeah, that makes sense. So that's possible. Yeah.
I'm gonna get the last one.
The last one's a little trickier because there's 2 of them. That's actually, we're probably going to get this done today. If we get there, we do one of them, that's awesome, but the goal is to get to this. Okay, let's try it. Let's see what it actually looks like. So, you're going to get things like this, where they're like, graph that, and you're going to look at that, and you're going to go, no. You don't know how to graph that. We've never graphed that before. We've never graphed 1 over something. You could throw it in your calculator and get the graph. My suggestion is do not do that because I know what types of questions are going to come on. And you're not going to be able to just graph them. So, if you want to be a lame duck and just do it in your calculator and be like, oh, I'm so much smarter than you, it's not going to pay off. So you're going to have to learn the tricks to do it. Here's the trick. If we look at that, we look at just the bottom. We can graph that. We spent a whole month graphing those. So if we had y equals negative 2x squared minus 0.5, we can graph those. The green hard to see. No? We can graph that thing. We know how. The A value tells us if it's going up or down. So is that going up or down? Down, it's negative. The C value tells you your y-intercept. And your B value, which is missing, doesn't really tell you anything anyway. But if your B value is missing, that means that your y value is also a maximum or a minimum. That's all it's really telling you. So if we look at that, we have a lot of information. Your B value doesn't anyway. It's pretty useless. But we need to have it to be able to see the other values for other approaches. So let's start. Let's start with what we know. Our y-intercept is at negative a half. So right here, negative a half. I know it's facing downwards, but I don't know exactly how it's facing downwards. So what I want you to do is there's 2 magical points that would be very useful to know. You know it though, you said it. The invariant points. So if you can find your invariant points, you can complete your graph. Plus, it'll be super useful when we try to get the reciprocal. Because we have to find them anyway. Where do invariant points happen? 1 and negative 1. Our graph is facing downwards. Is it ever going to cross y equals positive 1? No. So don't even try to figure that one. But we can figure out y equals negative 1. So change y to negative 1 and solve for x.
And what is x?
X is going to tell us how far to the left or right those invariant points are. Right?
I thought invariant were always
The y value will always be negative 1 and 1, but the x value can be anything. So it could be here, it could be here, it could be here, it could be here, but it's anywhere on that. Okay, we're going to add 0.5 to both sides. So now I've got negative 0.5 on the left. If you're writing this on your paper, you probably want to split this column in half and just do your work on this side of the column now. I'm doing the whole board so you can see my work. But just so you know, don't write across the whole board like I am or you're probably going to run out of space. I'm only doing it because you can't see if I only work in half the board. Okay, so I've moved over my 0.5. I've got negative 2x squared. I'm going to divide both sides by negative 2. So I get 0.5 divided by 2. Negative 1 plus 0.5. Yep. The negatives cancel each other out. Square root both sides. So square root, and you're going to have the square root of 0.5 over 2 is x. But think plus or minus square root. Remember, that's what we always do now. That tells you your 2 invariant points. So if you do 0.5 divided by 2, square root it, what do you get? Try and do your calculator. 0.5 divided by 2, square root it. I think it's 0.5 again. Yeah. So we're going to do positive 0.5. So that would be over here. Over here. And we're going to do negative 0.5 over here. So those are going to be our invariant points. So just a quick recap. The first point I did was my y-intercept. That's my c value. The second 2 points I did were my invariant points where y was -1. So then I solved for x, which gave me -1 is my y value, and -0.5 is my x value. Or it gave me -1 as my y value, and +0.5 is my x value.
Wait, if those
Right.
what would happen to y equals 1?
You could have had y equals 1, but we knew our graph wasn't going up. Our graph was facing down, so we don't need to solve for the positive
So
one.
it does not always.
So what?
So the 1 -1 always.
Only if it crosses those points. So the graph has to actually go there to be able to be an invariant point. Or mine.
Yeah, but when you do have like a y equals 1 and y equals -1, which ones are your invariant points that x won't count?
So you could get more. You could. So if our graph was up here, and it crossed and then crossed and then crossed and then crossed, you'd have 4 invariant points. That's future problem, and we are going to cover that. Okay, I've got 3 points. Now I can connect my dots and draw my graph.
But how do you know what part goes out after?
You don't. You're just rough guessing. If you want a better guess, you can actually calculate points. Feel free to waste your time. I suggest you don't.
What does it? Okay, so the things would be 0.5 away from the -1.
Yes.
Got it.
Okay. Those are asymptotes. Straight up.
Like the slanted one.
What are
Like what we were doing over here.
Yeah, that's the difference. Is ours are these are quadratics, right? So that's why it's a parabola now. That's why it's all changed. And yeah. Okay. Who's pretty happy with drawing the quadratic? It is. This one is accepted.
You just find
Find
solve
3.
for x, which is given e for your invariant points, how far away
Yeah.
they are. And then dots.
Yeah, that's all you do.
You don't even worry about the one.
Oh, we're gonna get there. Okay, so for now, this is just a quadratic. And we don't want the quadratic. We want the graph for the reciprocal of the quadratic. So I'm going to erase all this. Everyone okay with me to erase that? Actually, I'm going to get away with it.
You're such a wizard.
Yeah, I'm going to. Okay. I'm going to do red for the entire thing. So green is the quadratic. Red is my actual reciprocal of the quadratic. There's 3 steps. Let's review from yesterday. The first step was what? Find your asymptotes. Where is there always at least one? The horizontal. That thing's never going away. That one always exists. Now you need your vertical asymptotes. And if you're looking at a graph, your vertical asymptotes happen wherever you have an x-intercept. Where's our x-intercept on this graph? You don't have one. That means you don't have a vertical asymptote. So you've already done your asymptotes. You've drawn them in. That's excellent. The second thing you have to do is you have to find and mark your invariant points. Luckily for us, I made us do it. But if you didn't, you want to mark them. And they're at y equals -1. So right there, there. Your third step is reciprocate. And me and Mishab had a nice debate over if that's a real word or not. we created it as a word. We know it's actually a word. I'm convinced it is. He's convinced it's not. Well, you could have Googled it, but then you're supporting evil people at Google. So I tell him, I text him, I was like, just so you know, every time I need to know something, I ask Jeeves.com. He's like, what's that? It's a really old Google that used to suck. Google was way better. So Google did really well, and Ask Jeeves
Just
did
go to
not.
Bing. Just go to Bing.
Bing, I also tell him that, I'm like, I Bing everything because I hate you. It's the worst. I always ask him if they're looking to hire at Google. And he says things like, "We've looked at your search history and you're not welcome here." Like, that's pretty funny.
You're like, okay.
I was like, yeah, it is cute. So you're gonna reciprocate. You're gonna reciprocate, but you're gonna reciprocate a little different than yesterday. You have to go reciprocate your maximum point or your minimum point first. That has to be the first thing you reciprocate. So that's what we're gonna do. We're gonna figure that out right now. So this is what reciprocate means. Go to your maximum. It's right here. I'm gonna draw it. It is 0.5.
Wait, so is it
So
like a
negative.
Just wait a minute. Shut up. So your max is equal to 0.5 or negative 1/2. 0.5 is negative 1/2. Same thing. If I want to reciprocate that, you flip the top to the bottom and the bottom to the top. So now it becomes negative 2/1. So your maximum point goes from negative 1/2 to negative 2. So that's called reciprocating your maximum or minimum point. You just take the number and you flip it. And you only do that with your max or your min. You could do it with any single point on the graph. But when I'm marking things, or when we're doing tests, there's only 3 points you need. The max, min, and the 2 invariant points. And in the future, possibly the 5. That's the future. So, pardon? Tomorrow. It makes it's not any harder. It really isn't. So you've taken your max and you've reciprocated it. Does that make sense how I reciprocated it? Beautiful. Now you've got 3 points. Now you can connect your dots. You know you're going to get closer and closer to your asymptote point. So my graph must go like this. Forever.
It looks like a bird.
Kind of.
Oh, what side?
Let's
Should it
see.
be like round?
It looks
It
like
should be rounded.
Okay. I was round.
It shouldn't be so sharp.
This is like the weird. What even happened to graphics? It used to make sense, but now it's like so
I
many.
remember graphics Michael Jackson's Ghost in grade 9, and that made sense. What? Oh.
My graphics got a slide
I've
and
got-
they deleted it at the final exam.
Okay. Okay. Now that we've had an interlude, let's see if we can remember all of that. Okay, ready? You get a question. You look at this question and you go, I don't know how to graph that. Which is fine, because we don't know how to graph it. But what we do know is we know how to graph this quadratic. That's unit 2. We spent a long time graphing just that. What?
It's like, instead of figuring out the quadratic and stuff, just learn how to graph it.
This is how you learn to do it. So the way to do it is to do the quadratic and then reciprocate. There is no other, there's no nice form for this that we can turn it into, where it's like, oh, that will be my invariant point, that will be, it doesn't work that way. It'd be nice if it did, because then it wouldn't be so hard. But unfortunately, it is hard. So what we have to do is do what's easy. The bottom part is easy. We can do that. So if we're looking at that bottom quadratic, if we're looking at y equals negative x squared minus 1, that tells me my y-intercept and the direction of my quadratic. Where's my y-intercept? Negative 1. It's my c value. Which direction is it going? It's going to go down again. So it's going to go this way. So that's fantastic. Now we need to find 2 more points that would help us graph this thing. I always said find your invariant points because it's useful to find your invariant points for the next step. But here's my question. If I'm already at negative 1 and I'm going downwards, am I going to have any invariant points? I'm not. I'm not going to have any invariant points. My maximum is an invariant point. So that's going to be my invariant point. So I'm already kind of stuck. The resource tree is a vertex. There's no B. There's no B value. So if there's no B value, it tells you your vertex. Because secretly, I'm going to blow some minds. So if you're good with understanding that that's just going to be my vertex, you just keep on keeping on. If you're not good with that, I'm going to show you something cool. We're in general and standard form at the same time right now. So there's this form, which everyone's like, yeah, that makes sense. We're in that form. But we're also in this form at the same time, which gives you your vertex at P, Q. Your P value is 0. So your vertex is at 0, negative 1. Right there. So secretly we've been in both modes at the same time. But both modes. We're gonna pretend that that's not happening. And if you don't know what I was talking about, that's cool. Don't need to know.
I don't know what you're like either way. That's awesome.
So this is your vertex. And it's your y-intercept. The next thing you need to find is 2 points. We said before, find your invariant points. Because it was just going to be useful in the future. But we can't find our invariant points because that is our only invariant point. So you're... Pardon? Invariant points are points that will be on both graphs. So that's the perk of it. Now, the problem is,
There's only one. That's just a dot.
it's just that one. So you need to find 2 other points. My suggestion is find when x is equal to negative 1 and find when x is equal to positive 1. Because those are our next 2 points on either side. Mine.
Are we ever going to have a general form of the bottom where we have to find standard form?
Is there no?
Probably not. If you do, if that does happen, which it won't happen, I don't think. You can always just take this quadratic, and you can graph that. Your graph calculator. So if you get one and you don't remember how to graph the quadratic, you can do those in your calculator, and I don't mind you doing that. What I don't want you doing is graphing the reciprocal in your calculator, because I know that the questions that have that are going to be trouble. So just trust me when I say, if you can do that one, don't do the whole thing. Okay, x equals negative 1. If I put negative 1 in, it's squared. Makes a positive 1. The negative makes it negative again. Negative 1 minus 1 is negative 2. So it's going to be right there.
But for the reciprocal, it's going to be...
I know, but you're getting sick. Time. What? I'm finding 2 other points on the graph so I can make my graph. That's all I'm doing. It's just called finding 2 points on the graph. There's no name for it. They're not invariant points, they're just points. Okay. Reset. Ready? Invariant points are when y equals positive 1 or negative 1. Not when x equals positive 1 or negative 1. The only reason I'm finding x equals positive 1 or negative 1 is to find 2 more points, which are here and here, so I can draw my quadratic. That's the only reason I wanted them.
Because your graph
Yeah, because I was at 0, I just wanted to find 1 more to the left and 1 more to the right. Time.
So you just plot it so you don't have to-
Yes, exactly. You could have. Yeah. It's just find 2 points. Just create your graph nicely. That's all we're looking for.
Why could you do that for other reason why you can't just
Why I can just find points?
feel like this points like how can you find those 2 points?
I can choose any value for x and find any point. Like that's what equations actually tell you. They say y is equal to some sort of function around x. And if I pick any x, it'll tell me the y coordinate for that x. So that's kind of what it's just telling you. It's saying if you put any x in here, it'll tell you where on the map it'll be. Emily. I did one A1 because it was the next one on either side. So I was at 0, and I knew it was headed downwards, and I knew that my next thing I would cross would be negative 1. So I just wanted to figure where it was, and I knew my next thing I would cross would be positive 1. So I just figured it out. You're right.
If the y is equals to positive 1 and the it opens upwards, would it be the same thing?
You just find 2 points to be here and here. What you would find is you'd find your x-intercepts. And that's, again, that's a few.
So like if the y is
Yeah, find 2 other random points. Okay, so all we've done right now is we've graphed the quadratic. That's all we've done. And if you're totally lost on that, you can still graph quadratics in your calculator, and that's fine with that. What I don't want you to do is graph your reciprocals in your calculator. So you need to be able to go from quadratic to reciprocal of that quadratic by hand. What are our 3 steps? Step 1, draw your asymptotes. Your asymptotes are always at x-intercepts and on your x-axis. We've got one right here, because it's always there. And we've also got them anywhere that we cross the x-axis. And we never do. So we have no vertical asymptotes. The second step is what? Invariant points. So that's anywhere that y is equal to 1 or y is equal to negative 1. We have one spot right there where y is equal to negative 1. That's your only spot where you have an invariant point. So in this case, there's only 1. Your next thing to do is reciprocate. Yeah. Now, if you're clever and you've memorized your possible pictures, you have figured out that this one must look like that. Something simpler. Now, if you want to be a little more precise, take the other points you found and reciprocate them. So this point right here is at negative 2. The reciprocal of that would be negative 1/2. So this point would be here. And you can see my graph is a bit off. This point over here, y is negative 2. The reciprocal of that is negative 1/2.
The reciprocal of that is just like a point on
On your new graph.
Really angry face. No, look. It looks like a really angry
He does look really angry.
Oh no, we're all
So your graph, graph looks something like that. Is it precise? Obviously not. Do you see who drew it? Me. Josh.
Okay, so the red part of it, like, I don't know how far away it is from the x-axis is.
You should get closer to it, but never touch it. That's all that matters. So you want to be just arcing closer to it, but never touch it on both sides. Get as close as you can, Josh, is my suggestion. Ah.
So when your points are to be reciprocated.
Okay, you know what helps? If these three shut up, right? That helps. Yeah. It's like I had to take when I taught in like an elementary school for a week. I had to take whiteout away from little kids. I don't expect them to do that to 16-year-olds. So stop playing with whiteout. Okay, go ahead, Todd.
So points are 1 and 1/2. Or sorry.
1 and 1/2, negative 1/2.
Like,
Yes.
If I had like every 1 comma,
Yes.
negative 6.
Yes.
Plus 6.
Yes.
And how did we find the original points? So no,
The green,
yeah.
the green points, we just graphed them. We put -1 in for x and 1 in for x. That gave me my 2 original points. Okay. We're going to try another one. So, we have new graph. We know graphing this actual graph is difficult. So what we're going to do is we're going to graph the bottom only. And if we look at that, it's in vertex form. So it tells us where our max or our minimum is. By having x minus 1, it means your maximum moves 1 to the right. And there's no q value, so we just know our max or minimum is right there at 1. No, it always goes to wherever that is. That's our vertex form.
Is it like good to have it in vertex form?
It helps, because then we can move our vertex around and start a graph. So it is useful. The next thing we need to do is we need to find a couple points. I suggest finding your invariant points, because I know in the future it's going to help me. Like, save yourself time. You could calculate other points, but it's just going to cause you more headache. So I'm going to find my invariant points. To find my invariant points, they're equal to when y is 1 and -1. Our graph, is it going to go upwards or downwards? Up, because our a is positive. So, am I ever going to have y equals -1? No. I will have y as a positive 1, though. So what I do is I make y 1, and I solve for x. So, remember, we're not trying to graph the big thing. We're graphing just the bottom. That's why. I'm going to divide both sides by 3. So it's 1/3 is equal to x minus 1 squared. I square root both sides. So the square root of 1/3 is equal to x minus 1. But I remember to do a plus minus. If you didn't do that, you're only going to get 1 point. Plus minus gives you the second point. If you FOILed that out and did all that, you're going to make your life a little bit harder. So if you were trying to solve this, you FOILed out and then divided over and tried to figure it out, it'll work. It's just going to be a lot more work. We then add 1 to both sides. So it's 1 plus or minus the root of 1/3 is equal to x. That gives me 2 points. If you punch that in your calculator, if you went 1 plus that, you would get 1.6. Just about 1.6. So you'd be somewhere over there. If you did 1 minus that root sign, you'd have somewhere close to 0.4. So I now have 3 points. I have a vertex, which also happens to be an x-intercept. And I have two other points on the graph, which are invariant points. Now, I can connect my dots. My graph looks something like that. Now that I have my graph, I can reciprocate it. I have 3 steps to reciprocate it. Step 1. Asymptotes. Your asymptotes are anywhere that you have an x-intercept. We have one right here. So draw that. Your x-axis is your other one. Yeah, dotted line. Your second step is what? Invariant points. Now, we're clever, and we already marked them. They're here and here. If you hadn't marked them yet, that's the step you mark them. Your third step is reciprocate.
So you have 2 lines.
Now, to reciprocate. Invariant points is on your graph where y is equal to 1. So there, and go through us in there.
Always 1.
Always. It's always when y is 1 or y is negative 1. And if you're ever wondering why, like if you're wondering why and how we know that, if you took y equals 1, and then you reciprocated it, it's equal to 1 over 1, which is 1. So that's why they don't move. And the same thing works for negative 1. So if you had y equals negative 1, reciprocated, it's 1 over negative 1, which is just negative 1. That's why those points don't move. There's a reason for their mathematics. We don't have any. Yeah. Okay. Reciprocate. Now, you have to reciprocate your maximum point first, or your minimum point first. But we can't. Why can't we change our min or our max? Because it's on the asymptote. It's going to disappear. Right? That minimum is on the asymptote, which means it's not possible. So we don't need to worry about reciprocating. We just have to reciprocate this graph. Pardon? Go ahead now. Okay. Your vertex won't reciprocate because it's on the asymptote. But the rest of the graph will. It'll look like this.
What do you mean the rest of your graph?
So every other point on the graph can reciprocate. So if we went up to here, for instance, where y is equal to 4, what's the reciprocal of 4? 1 over 4. So that point's going to now be at 1 over 4. You go up here where this point is 5, and you reciprocate it. What's the reciprocal of 5? 1 over 5. So that point jumps all the way down here to 1 over 5. Sorry, we're reciprocating.
Sorry.
No, we're reciprocating the green line.
So you can't.
Well, then technically, never means like lower or never touch lower than
Wait, let's go off to infinity. Okay, end up. Ask a question.
What numbers do I use for the reciprocate?
You don't, honestly, you don't have to use any numbers. If you just know it's going to look like that, just draw that. But if you don't know that, then pick any numbers of your choosing, any y value you want, and it'll remind you of how it looks. So if you're like, okay, I've got my green graph, I've got my asymptotes, I've got my invariant points right here, and you're not sure what this graph looks like still, And be like, oh, I don't remember that it looks like that. You can pick any point you want, any y value. So pick y equals 2. Okay, where is y equal 2? Right there. Now reciprocate y equals 2. So now it's 1 over 2. So it's now at 1 over 2. And you're going to create little dots. So I'll do the blue to demo this. So I took 2. It reciprocates to be 1/2. So we're going to look here. It's actually pretty good drawing. I'm going to take y equals 3. What's the reciprocal y equals 3? So this point now moves down here to 1 over 3. Like this. Where would 4 go? It would go to 1 over 4, which is all the way down here. And that'll be start with your graph, and then you'll kind of be able to know, right? And it has to go through those points, and it has to go through your invariant point. And you know you can't cross your asymptote. So once you were following that pattern, and you started to get your asymptote, you just know to trail up.
It just falls.
It just follows that asymptote to the root. That's all it does. If you're wondering why. Does that make sense, Emma? So if you don't remember the general shape of things, that's what you can do. Okay, we got one more. We've got 3 minutes. So watch how fast this goes. This is how fast I want you to be able to do a question. You're going to look at this. You're going to go, I know I can't do that. So you're going to graph the bottom. The bottom is going to look like this. Well, I have a vertex that's to the left. I also know it's facing downwards. I calculate my invariant points. So 1 equals negative x plus 2 squared. Negative 1 goes to that side.
Isn't it
Oh, sorry, yeah. That's why I got lost. It touches negative 1 because it's going down. Thank you. So I divide by a negative, makes it a positive 1. Is equal to x plus 2 squared. Square root both sides, and you're going to get 1 still. Subtract 2 from both sides, so you get a plus or minus 1. We square rooted, right? Square rooted that. You're going to go negative 2 plus or minus 1 is equal to x. So that gives me my 2 invariant points, which are going to be here and here, which gives me a graph of that or that. My step 1, asymptotes. My step 2, invariant point.